Okay. So first of all, what we need to do is to create IP packet. So the syntax is very simple. Let's call it IP. Okay. Next, we are going to send DNS packets. So we need to create UDP packet first. Okay. Then we need DNS packet itself. And DNS query, as we are going to put query inside DNS packet inside UDP packet, and UDP packet inside IP packet, and then we are going to send it. Our packets as well, they are empty. Let's add IP to our IP packet. So if we will not add specific IP, our default internal IP will be used. So what I'm going to do is to write ip.dst for destination. And as we know, our DNS server located on 10.0.0.5. Okay, so now if we take a look inside our IP packet, we can see the destination is set inside. Okay. So now let's create DNS query. So there is many options for all packets, and if you don't remember all of the options, so you can just type DNSQR and see all the options we can add to a DNS query. Just type tab after the dot, and you will see the list of all options that can be used. Actually, we don't need all of them, but some of them we will use. So let's start with the first one, DNS query queue name is for query name. So we need to set the domain name that we want to look up. It's coopbank.com. Okay. As we want to amplify our request, so we will ask for all the records that bind to coopbank.com, and not only A or 4A records. So what we are going to do is to set query type to 255 to get all the data that is stored in DNS response. Okay, so we do it for 255. Is masking, so 255 means don't mask, and get all the information. It's like send any in DNS request. Let's set flag recursion enable. Oh. Let's set flag for recursion. we are going to send only one query, as in DNS you can send multiple queries, so qd count should be also 1. And now let's bind our query to our DNS packet. Okay, let's see what we have inside. Pretty print. If you want to pretty print the information inside, just type .display with brackets, and you will have it nicely with all the fields inside. So what we can see, we have DNS inside, we have query. It should be recursive, okay? And there is only one query. We are going to ask for kubeband.com, and query type is all. So we are going to ask for all the information that's stored in DNS. So now let's create our request. So we are binding IP to UDP to DNS. Okay, let's see inside. We have request with IP to destination ended with 5. Inside we have a UDP packet. Inside the UDP packet we have DNS packet with query information. So let's try to send it to our DNS server. Okay, so we send it and we received all this information. All this information is about the kubeband that is stored in DNS server, same as we did with NSLOOKUP. But now we can do it programmatically using SCAPI. Are you asking about this, DNSRR? Oh, SR1? Yeah, SR1 is like send the request, one request. There's different ways to send it, and the variance is if blocking or not blocking. So this one is blocking. Guys, by the way, if you are trying to reach server 10.0.5, you will not reach it because it's local server on my machine. But later, you can try to change the IP to my machine's external IP, and then we'll see your requests coming to the victim. Okay? So at this step, we can see all the information stored inside the request. Let's store this response in respond value. Okay, so one packet sent, one packet received, and see what the size of each packet. So request is 58 bytes. Response is 388. Okay, so if we divide, we have amplification factor of 6. Okay, and this is just an example. In real servers, the information stored in DNS is more than 388 bytes. But even for this simple example, we have amplification factor of 6. It means like we can use one machine is same power as we using 6 machines, okay, just by using the amplification technique. So at this moment, we sent these packets to DNS server, and we got the response back to our attacker's machine. So now we can spoof the IP. If we take a look inside IP, there is also only destination, and the source IP is not set. So if it's not set, it used our default IP. So let's set source IP so the packet can go to the victim server. Okay, now you can see that also source IP and destination IP are set. The source IP is victim's IP, destination IP is our DNS server IP. So now the request will be sent to DNS, but the response will be directed to our victim. Okay, we can see the full packet with IP, UDP, DNS inside, and spoofed IPs. And now I'm sending it to... Okay, now the packet sent to the victim. Need to restart the capturing. Let's do it again to see the packet captured. Okay, we can see now that packet received from source that is our DNS server, but the destination is Windows machine, while I send it direct from my Kali Linux. Okay, so we spoof the IP, and now it's sent there. And the packet size, as you can see, is 402. Its packet size include TCP and IP headers. Okay, so it's amplified by 6. So okay, so let's make it more fun. We send only one packet to see the example, but we can do it with for loop, let's say for 100 times. Okay, so now take a look in our machine, victim machine. It received all these spoofed packets with DNS amplification. So this technique is very good. It's very common in all in real attacks. Okay, as you can use legitimate DNS servers, you can use any server that hosts information about domains. You can spoof the IP of the victim, and then the victim will receive traffic from legitimate DNS server, okay? And now he need to deal how to filter out legitimate responses versus attacking responses. Okay, any questions till now? Yes. The source IP of these packets. Yeah, but the victim received these packets, as you can see, with source IP of our DNS server. So this IP is legitimate. He even don't know the IP of the attacker because he spoofed his IP. Okay? So if we try to use, for example, a Google DNS server, okay, all the responses will come from Google's IP. And your mitigation system or your IT should understand where it's spoofed attack and where it's legitimate responses to legitimate requests. Okay, so this is the way you can use it. You can try to make it yourself. I will show the instructions, and if you have questions, you can ask. Change the IP to this one and use port 9053. Hopefully, will not block us. So you can try to send spoofed or try with direct requests, okay, to this IP with this port to see if you can reach the DNS, and then you can spoof it. Try first to create this command. It will create an lookup request to my machine with port 9053. If you have success, means you can reach the machine. If not, so we are blocked by firewall or by other network equipment. No response. So what the response is wrong? probably blocked by a firewall, something like that. Okay, so unfortunately we can do it here, but you can practice it at home if you have, and this is the example, okay? Just set up 2 machines or 3 machines, depends if you want to attack from your host or from virtual machine. And you can repeat all these instructions and see how it works, okay, as we have seen here and now. Yes. This is my IP here internal, but probably it's blocked by, because all the demos I do in virtual machines, local network, but I open NAT ports for this specific. Okay, let's continue from there. We talked about network layers attacks. We started with SYN flood, and then we created DNS amplification, and so the factor of application factor of 6. And now let's move to application layer attacks. Okay, so we have seen that there's 2 types, and they have big differences. So when we are talking about application layer attack or layer 7 attack, let's do some quick recap about HTTP request. Okay, HTTP request is, this is just an example how it looks. It has headers. Okay, it can be GET or POST or HEAD or any other type of request. Some meta information, and if we have a POST, there is a POST body. Okay. This request sent over TCP. So first of all, we need to create 3-way handshake, and then we can send GET requests or POST requests to our server. When attacker come to your website and try to find weak spots, what he will find here? Any ideas? What the attacker will look to find and understand how to hit your server? Login form, yes. Pictures? Yes, pictures. Search form. Exactly. This is 3 examples that we have here. Okay. Large images. Okay. If you need to download large images, the attacker don't care about the response, but you will send, or your server will send these images if they are not cached, and again and again and again, and will hit your resources as well as outgoing pipe. Login and search is also weak spots because the access database, okay? For example, in search, if you know how the tables looks, if, for example, most of the time we search for prices, and it optimized, the database optimized and indexed to search for prices and sort from top down, and now you search for some tools and sort it by manufacturer, it will take to database to sort it because it's not indexed this way. So you can manipulate search to hit the database. And actually, this is exactly the example I'm going to show you. So as well, you can go to this demo site. The IP I showed before, I'll show again. Just type /cp, and you will get this page. And again, just small example. We have Kali as an attacker, Bank as our victim server this time, and we'll show how DDoS attack will affect user experience. Okay, so you can go to this URL and see Kubak website. Okay? So if you can open your network dev tool in Chrome or Firefox or any browser you use, let's set it for preserve logs and filter it for search. So we'll see only search information. Now let's try to search for branch of KubeBank. Let's say Kathmandu. Okay, it takes less than 1 second. It's 947 milliseconds. Let's do it again. Okay, 840. You can try to do it by yourself to see that the response time should be around 1 second. So when the attacker located our web server and found weak spots, what he will do, he will see that our search request sent us get, okay? So actually, he can search for anything just to change it in URL, and it will execute queries in our database. So this is example, very simple script. It ran 1,000 times and create search request for the KubeBank, okay? So I'll execute the script and show you how it will affect the response time of our web server. So I'm going to execute the script. Yeah, I have typo in servo. Okay, let's try to search. Quick. Oh, it's even worse. We have database error. It's too many connections. Okay. Let's try it again. No. I think I killed the database. Okay, you can see how the attack affect on user experience. It was less than 1 second in normal time, but during the attack, if the database is not got down, we have almost 8 seconds, okay? And it can increase. If I create a more faster attack, it will go up and up. Okay, database is down. Okay, it's too hard to VM to handle it. So you can see it was very, very easy, just simple script. Okay. Very simple script. All it's doing is requesting with some random search strings that should go to database, not founded, and as it opened a lot of connections, it's clogged the resources of the database. Okay, so it can affect user experience. And there is nothing to do in network layer to mitigate it. Any questions? Okay, so we have seen network layer attacks, application layer attacks, and now the hottest topic of last years is IoT and IoT botnets. How many of you heard about Mirai? Okay, so Mirai is a good example of IoT botnet that hit Dyn server and many others, and now it has like more than 100 forks from this source code. So IoT is actually any device, smart device that can connected to internet. And according to researchers in 2020, number of IoT devices connected to the internet will be more than 6 billion. So if any one of you has one laptop, one mobile, you can have many smart devices like watch, TV, smart refrigerator, etc., etc. So the number can grow exponentially, and number of devices connected to the internet. So why to use IoT for DDoS? You know, hackers don't wake up in the morning and think, it can be cool to hack some cameras and install code that will attack other servers. It's just cost effectiveness. It's low-hanging fruit. There are many, demographically, there are many than computers. They are not protected. They have vulnerabilities. And in most cases, IoT vendors, they don't care a lot about security of IoT devices. So by definition, IoT have more internet connections and as PCs, so it's easy to use. As well, it can execute code. Most of them run simple Linux version like BusyBox or any other fork of a small Linux machine. So you can execute your own code. Very simple. You don't need to hack the firmware or something else. Same as PC. Scannability. So most of the computers and servers, they have some firewalls, they have antiviruses and different local protecting software. But IoT is lack of resources, so you can't install firewall or antivirus on your web camera, so they are not protected, and they are scannable from the internet. Are they hackable? Yes, they are, and it's very easy, okay? As I said, most of the vendors don't care about the security of IoT devices. So we have all this for IoT. We have internet connection, so we can reach them. We can execute the code. We can scan them, so we can easily find them on the web. And we can hack them. So they are really that hackable? Yes, they are. And we'll do it right now with you. So we'll try to find some IoT devices that can be hacked. So first of all, I want to explain what is CVE. Is a common vulnerability and exposure. It's a way to share that there is a vulnerability in some device or some software or some hardware. And actually, the manufacturer or the vendor should patch this software to close the exploitations of the vulnerability. But most of them don't do it or can't do it. Like, for example, IP cameras. When you send your IP camera, how will you reach your customer to say them, okay, you know, I released this camera with some vulnerabilities, so now you need to restart it and set new firmware. It's a very complicated task after you sell your devices. So this is just an example of some vulnerability in home routers that was exposed like 1 year ago. And you can find many like this in the web. This specific vulnerability in TR69 protocol. And we can scan it in the web to see if there are such devices that have this port open and we can access it. So we'll use Shodan to scan the device from Nepal, for example. Okay, there are 600 routers with open port 7547 here in Nepal. So let's continue and search for specific provider, okay? Let's say, for example, if we know that it uses not patched firmware. Okay, so now we have 300 devices with open port from specific provider that in one click I can find in web, okay? I can scan all of them and see if the port is open and I can hack them. Easy way to create your botnet, okay? So, let's create some interesting stuff and find some devices that are really not patched. We will not hack them, but I will show you how easy I can find them and how easy we can access them. The vulnerability I will use is some version of firmware for IP web cameras called JAWS version 1. Okay, we have 29 cameras with this version, okay? Let's try some of them that are already connected. Okay, I just accessed the IP. Nothing special. You can guess what the password is here. Okay? Moreover, if you're not familiar with some Easter egg in Linux, there is moo function or apt-get moo that's hidden inside Linux machines. Okay? Moo is executed here. You can dig deeper. It's just one step before you search for the vulnerability and hack this camera. Okay? So it's super easy. It's super easy. It took me less than 1 minute to show you how can I find cameras here in Nepal that I can hack. Okay? So if you want to do it automatically, Shodan is awesome tool that we can create some Python script. It has API, so we can execute it and find all the devices that are vulnerable to specific vulnerability, check them, and we'll find we will create this botnet just in a couple of minutes. I'm not going to hack them, but I will show you how can I grab all the information from Shodan, okay, using this simple script. All it's do is just load in Python Shodan API, have a key, and then I search for, let's change it to the cameras. Okay, we are going to look for JAWS 1.0. Let's see how many do we have here. I think there is some issue. Okay. Okay. We have almost 20,000 devices with JAWS 1.0 version. Probably most of them are not patched. Okay? So if we look inside and search for such devices in Nepal, and we want to see their location and IP, okay? This is all the cameras. This is exactly what we saw here. UI version of Shodan. This done with 5 lines of Python script. Okay? All these IPs, Nepal, Kathmandu, Jawal-Kahel. Okay? So just imagine how much it will take to attacker to create new botnet when new vulnerability will be exposed. Much faster than any vendor will patch all these IoT devices. Okay, so just Iot Ddos history to understand the size of it. Mirai, many of you heard about Mirai. This was like big boom in Iot Ddos industry. It was released in September 20, day before or day after. After that, just after the release, there was huge attack on OVH French ISP that reached 1 terabit per second. Okay, it's huge attack. Later, probably most of you remember the attack that disconnected half of the US from the internet, attack on Dyn, also used by Mirai. Later, attack on Deutsche Telekom network and attack using TokTok. TokTok is ISP in UK, so the attacker hacked to all the routers in the UK and then used it for attacks. But Iot DDoS not started in 20 September 2016. It started much before. We have seen in Encapsula and in Perva attacks from 13 December 2014 from Soho. Soho is small office, home office routers that created DDoS attacks. We even found DDoS camera in our backyard that was hacked, used in DDoS, so we could take a picture from this camera. Okay? And it's continue. Okay, we all the time hear about new and new variants, and after Mirai code was released publicly, we have seen more than 100 different forks from source code that try to attack in different ways, that communicate to command and control server different ways. Even bots that try to patch these cameras, like Hajim, the bot that tried to reach the cameras before Mirai and close the door, close the open port. And it's continue, okay? So I just want to show you how attack from such botnet was discovered in our network. So we drill down the TokTok botnet. On December 6, 2016, we have seen huge spike on one of our customers' Bitcoin exchange server that reached more than 7,500 requests per second. And if you can see, the attack started in the morning of December 6th and ended after December 8th. So it took like almost 3 days, non-stop, okay? So if you have a website that can't handle it, you will be out for 3 days. When we dived in, what interesting we found, we have seen that our classification system found that the request generated by wget BusyBox. BusyBox is small Linux distribution that used in IoT devices, like cameras and like routers. And it has very funny user agent. Okay, and it was blocked as bad bot during DDoS attack. So when we digged in and searched for IPs that participated in this attack, we found that most of them use Huawei Home Gateway, okay, with ROM pager 407 that was vulnerable from 2002. Okay, this attack was in 2016. No one patched it for 14 years. Okay, and there was patched in 2005 and in 2007. Huawei patched ROM pager, or I'm not sure if Huawei are responsible for ROM pager, but it was patched. There is another versions like 4.3 and 4.6 that patched this vulnerability. But specific TokTok and their routers, they use this version for 14 years. Okay? So something that is not common for DDoS attacks, all of the attack came from same country. Okay? If you are creating botnet, you will search everywhere. Okay? You don't care if the attack or the botnet will be in UK, Europe, Asia, Africa. Never mind. But because the vulnerability was in specific firmware version used by ISP, TokTok, so the attack all the IPs came from UK. And the common was that belonged to TokTok ISP. So another common thing was TR69 protocol. So where does the vulnerability come from? TR69 is a customer premises equipment protocol. So it will used by ISPs to control your home router. So if you call to support, they will not send you a technician home to fix and update your router. They will do it remotely using this protocol. So it should be close to any IP from the world except the IP from ISPs, but not all the ISPs do it. Moreover, it has some vulnerability in the protocol. So it used to synchronize time as well. So when it synchronizes time, it's go to NTP server and try to get data. But you can send some malformed request with, instead of time from MTP, you can just close it with a quote and then go to wget inside the router and download your malware and then execute it. Okay? So this line will execute the malware on the router. Okay? And it's super easy. Just send this request to vulnerable device. Okay? When we search in Shodan for these devices, we found that before the attack, like for example, November 13, the port was open. But when we search for IPs, after the attack, the port was closed. And this is example of Mirai or Mirai fork. Because when Mirai reach the device, it closes the port so no one can patch it, okay, until you restart your device with default credentials, okay? So this is example of Miref. So what are mitigation strategies for such attacks? Let's explore some myths, or actually let's smash them. First of all, only, and you can feel it, matters. So as we can have seen before, not only one thing matters. The attacker can hit different resources in your network. It can be router, it can be firewall, it can be database. Moreover, as I mentioned before, most of the attackers use multiple vectors, sometimes concurrently, sometimes they try one and then switch to another. And here you can see that most of the attacks, they come from TCP and UDP. And if you count here, there are more than 100%. And the reason is that most of the attacks, they combine TCP and UDP, or they combine DNS amplification with some UDP traffic to confuse your mitigation system. So not only one things matter, there's everything, all the systems that are relevant. I'm not a target. This is a big mistake, okay? We have found that during Valentine, last year, not this one, actually it was 16, February 16, the attackers attack some florist shop, okay? So it's good technique if I have florist, and many people like to buy flowers at Valentine Day. So if I hit your shop, more customers will come to me. So never think that you are not a target. Even if you are sell flowers, so you can be a target because you have a competitors. DDoS are run by masterminds. So they're run by kids, okay? And you actually, at this session, you try to do it yourself. Okay, you found freebooters, and you could pay $20 and try to hit the server, and it's super easy. You don't need to be a mastermind, okay? And the scripts I created, it's just a couple of lines. So if just small understanding of what you are doing, you can do it easily. So just a reminder, okay? If you don't know how to do it, you can pay it, and it's not expensive. Just some downtime. It's big mistake, okay? Your uptime is your business time. So if you are down, you are not working, and your reputation is affected, okay? And if we look, we can see that attack duration is not just some downtime for like 1 or 3 minutes, as you can use with freebooters. Most of the attacks, if you can see, it's more than 70%, they've been longer than 30 minutes, and more than 40%, they're longer than 1 hour, and some of them have been for 12 hours and more. So if you can be out of the business for half a day, I'm not sure. I like this picture from Silicon Valley comedy show. If you have seen it, Box would not fix it, okay? Why? Because bottleneck, okay? If you place a box that's crap in your gateway and your bandwidth is 10 gigabit, attackers can send 20 gigabit, so your box will do nothing with this. So you can use a box to solve these issues. More bandwidth, less downtime. It's a big mistake. Okay, if you buy bandwidth, it will not help you. And we have seen before, okay? In HTTP attack in layer 7, bandwidth is very small, much lower than your capacity. But the issue is here in your web server. There are too many sessions that you can't handle it. So it doesn't matter how much you will increase your bandwidth, they will try to hit your servers in other ways. And DDoS protections are all the same. It's hard to say. When you choose your DDoS protection, you need to think about false positives and false negatives, okay? Because I can tell you that I can protect you. I will null route all the traffic during the DDoS, so the attackers will not reach your system. But if I will null route your traffic, I will null route all your legitimate customers. Okay? If I tell you that I give CAPTCHA for any request that come to your website if you are during DDoS attack, okay? I'm not sure you want to receive CAPTCHA or get CAPTCHA for any request because it's a bad user experience. So when you evaluate DDoS protection, you need to think about all the aspects, not only about the price or only about one way it's mitigate. Does it mitigate all type of DDoS? How deal with false positives and how deal with false negatives? Okay? So what are the conclusions from this session? So DDoS attacks is easy, okay? You have seen it. It's very cheap, okay? I think most of you can afford $20 DDoS attack if you need it, and the value is good. There are many vulnerable devices that can be exploited in any time, okay? Just with 2 clicks, search for Shodan for any device, and you can hack it. You only need to know what vulnerability it has and how to exploit it. DDoS can hurt you when you are not prepared, okay? Many customers that come to Imperva, they say, oh, I'm under DDoS attack, okay? You need to think about it before to be prepared, as you can be a victim. And mitigation is more complicated, okay? You need to think about all the aspects of mitigation. If you do it by yourself, how you deal with bandwidth, how you deal with packet per second attack, how you deal with amplification attacks, and how you will deal with application layer attacks. Okay, and the last, if you want to learn more about DDoS, you can go to this website. There is cool examples, lots of hands-on you can do by yourself. And if you have questions, it's a time. No questions?
Either it was so boring that you are all asleep, or no questions, really?
So in next session, when someone will ask, have you attacked someone using DDoS, you can say yes. You attacked my VM.
Exactly. So Dima, oh, one question. Afifa.
So it's a good question. So it's better to be prepared in advance, but if you are not, you actually can reach companies that can give you protection, okay? It will take some time to set up, but many of them can do it fast. Okay, they will set up the devices to divert the traffic to scrubbing centers and then forward you only the clean traffic. It's much harder to doing under the rush, okay, and rush time, but it's possible. Any other?
Last chance to win a t-shirt. It always works.
I think they are the same. In our research, we found that half of the attacks, or let's say half of the victims attacked by network layer attacks and half of the victims attacked by application layer attacks. There is some correlation between them because most of our customers, all of our customers actually, they are protected. So in many cases, when attackers try to attack them, they see that they are protected by encapsula DDoS mitigation, and they leave it. In some booters, even if you try to attack encapsula IP, they will tell, okay, we know this IP, there is no chance it will work. There are OWASP WAF that can handle some of the attacks. Okay, but as you know, open source is open source. It's supported by community, and the value it brings to you is not as good as any solution. That there are many research behind the solution, not only the end-to-ism. Sorry. I forget the word in English, how to pronounce it correctly. Okay, so open source, there are solutions. I didn't check the quality of them, but from what I know, they can do it, but they can do it for just simple attacks, okay? If the attacker wants to hit you, they will find for some weak spots, and he will bypass this open source solution because he can investigate how it works before he will try to attack you. Yeah, I completely agree with you, okay? So in open source, the issue with open source that when you can be on a white side or a black side, okay? If you find some vulnerability in open source, you can sell it in black market, for example, or you can be a good guy and patch it, okay? And this is the issue, to find vulnerability in some enterprise solution. It's much harder because it's closed source.
I also agree with you, and my personal disclaimer, I did a master degree, my master degree on open source, so I'm also a fan. There are other aspects of the protection, as Dima mentioned, regarding volumetrics that won't be solvable with any, open source or proprietary software tool. They must be, diverted to the cloud in order to have the capacity. Okay, so with that, thank you for participating. Thank you, Dima.
Thank you very much. I don't know how to pronounce it in Nepali.